Hi folks, we're going to take a look at question 20 from page 121. And here they're giving us 3 points which represent the vertices of a triangle, and they want us to show that the centroid divides each median in a ratio of 2 to 1. So I'm actually going to do it for just one of the medians, okay? And if you want to continue on, you can do it for the other two, okay? And this is, what basic property of the geometry of triangles, that the centroid divides each median in this ratio. So the first thing we're going to have to do is find the centroid, and of course we need to make sure we know what the centroid is. So the centroid is the intersection of the 3 medians of this triangle. Okay, and let's remember that a median, okay, so if we draw a triangle, so let's call this P, Q, and R. Okay, what a median does is it joins a vertex to the midpoint of the opposite side. Okay, and then here this will join the midpoint to that opposite side. Okay, and the third will intersect at the same point. Okay, but as we saw on the demonstration on Geometry Sketchpad, I don't need to find all 3 lines. Since they're all going to intersect at the same point, I can just use 2 lines to determine that intersection. Okay? Now remember, if you don't know what any of these terms means, just Google it and put in centroid of a triangle, and this definition will come up. Okay, so the first thing we have to do is we have to determine this centroid. Okay, so I'm going to need to determine the equations of these 2 lines in order to find that point of intersection. Okay, so let's start by finding the equation of this first line. So let's find the median from Q, we'll call it. Okay, so I know that this line is going to pass through these 2 points. Okay, now not necessarily perpendicular, okay, keep that in mind, but it passes through Q and the midpoint of PR. So the first thing I'm going to do is find the midpoint of PR. Okay, so let's do that here. So midpoint will be -1 plus 1, -1 plus 1 over 2, and then here we have 2 plus 2 over 2, and that gives us, so this is 0, so that's actually kind of nice, and then here 4 over 2 is 2. Okay, now we're looking for the line that goes through this midpoint and Q, so we've got 2 points, meaning we can find the slope. Okay, so I'll call this the slope from Q. Okay, and let's calculate that. So we've got -4 minus 2, so y2 minus y1, okay, divided by x2 minus x1, so 4 minus 0. And here we have as our slope -6 over 4, which can be reduced to -3 over 2. Okay, now that we have our slope, we can find the equation of this line. Okay, so we're going to go into, okay, I'm just going to make sure I have nice titles here to make sure my sections are clearly defined. So here, take y equals mx plus b. Okay, and I can choose either 0, 2 or 4, -4. I'm going to choose 0, 2 because this actually defines my y-intercept. So I don't even have to do any work. I see that 2, because that's when x is equal to 0, is the y-intercept. So I can write this equation as -3 over 2x plus 2. Okay, so there we go. We have our first equation. Okay, so now the next step is I'll find the median from P. Okay, so here we'll do the median from point P or vertex P. Okay, and that'll be the next step. So again, I'm going to have to find this point here, which is the midpoint of QR. So the first thing I'll do is find the midpoint of QR. So here at QR we have 4 plus 1 over 2. And then here we have -4 plus 2 over 2. Okay, so that midpoint ends up being 4 plus 1 is 5 divided by 2, so 2.5. And here we have -4 plus 2, so -2 over 2 is -1. Okay, so now we can find the slope joining P and this midpoint. Okay, so we'll find that slope here. So here we got the point, so here we'll do y2 minus y1, so 2 minus -1. divided by x2 minus x1, so negative 1 minus 2.5. Okay, so here we have 2 plus 1 is 3, and we have negative 1 minus 2.5, which is negative 3.5. Now I don't want to leave it this way, so I should really simplify this. So I'll try to clear that up here. So instead of writing negative 3.5, I'm going to write it as, so put the negative up here. So 3.5 is the same as 7 over 2. Okay, so here this can be rewritten as 7 over 2, and I can do a little dividing by a fraction is like multiplying by the reciprocal. So this is negative 3 times 2 over 7. So here we have negative 6 over 7. Okay, now that we have the slope, we can use either the point P or the midpoint. Since the point P is nicer, I'll use that one there. Okay, so here I'll use P, which is negative 1, 2, and here's my slope. So let's stick that into y equals mx plus b. So the y value is 2 equals, and here we got negative 1 times our slope, which is negative 6 over 7, okay, plus b. So here b is equal to, so 2, I'll just write it right off the bat as something over 7. So this is 14 over 7, and here this is positive 6 over 7, so when I bring it to the other side, it'll be minus 6 over 7. Okay, and so the b value is just 14 minus 6, 8 over 7. So my equation, my second equation, will be negative 6 over 7x plus 8 over 7. Okay, so now the next step is to take this and find the point of intersection. Okay, so here we'll find the centroid, which is going to be our point of intersection. So we're going to have to use those two equations. Okay, so here we have y equals negative 3 halves x plus 2, and the second equation we found was y equals negative 6 over 7x plus 8 over 7. Okay, so since the y's are already isolated, I'll solve this by substitution. So I'll substitute this y by the negative 3 over 2x plus 2. That's equal to negative 6 over 7x plus 8 over 7. Okay, and of course I'm going to clear out these denominators. So I'll multiply both sides by the lowest common denominator between 2 and 7, and that's 14. Okay, so here we've got 14 and 2. Okay, that reduces to 7. So 7 times negative 3 is negative 21x. 14 times 2 is 28. Okay, now on this side here, 14 over 7 is 2. So times negative 6 is negative 12x. And here 14 over 7 again is 2. So 2 times 8 is 16. Okay, and now we can start solving this. So I'll bring the negative 21x to the other side, becomes plus. Okay, so negative 12 plus 21, that gives us 9x. And here 28 minus 16 is just equal to, so 28, 18, okay, this is just equal to 12. So x is equal to 12 over 9, or we can simplify that, and that's just divide both top and bottom by 3, so that's 4 over 3. Okay, now of course we're looking for the point of intersection, so we'll also need the y value, and here equation 1 is definitely easier to use to solve for the y value. So y is equal to negative 3 over 2 times our x value that we just found, 4 over 3, okay, plus 2, and here lots of nice stuff happens because the 3's reduce, and 4 over 2 is just 2, so I'm just left with negative 2 plus 2. Oh, in fact, I'm just left with 0. So my centroid, okay, is just equal to 4 over 3, 0. Okay, now what we have to show is that the centroid cuts a median in a ratio of 2 over 1. Okay, so here I'll pick one of these. So maybe I'll take the one that we called Q, okay, to this median here, and now we know the centroid is, we know the centroid is this point 4/3, 0. Okay, so I'm going to find the distance from the centroid to Q, and then the centroid to this midpoint. Okay, so which we call the midpoint of PR, and I'm going to show that the ratio is 2:1. So let's find the distance from Q to 4/3, 0. Okay, so that's just the square root of, okay, x2 minus x1. So here we've got the Q value is 4, -4. So we've got 4 minus 4/3 squared. Okay, and then plus y2 minus y1. So -4 minus 0 squared. So that's just 16. Okay, so let's clean this up here. So here we've got 4 times 3, so we got 12/3 minus 4/3 squared plus 16. So this just gives us 12 minus 4 is 8, so 8/3 squared, so 64/9. And then here we'll just write 16 as some number over 9. Okay, so let's see what that is. So 16, so 9 times 10 is 90. 9 times 6 is 54. So 90 plus 54 is just 144/9. And so here we're left with, okay, and this point here, maybe I'll just take my calculator. Okay, so what do we have? We have 64 plus 144 equals 208/9. Okay, so now we have to find the distance between the centroid and the midpoint. Okay, so I'll just finish this off here on this other sheet of paper. Okay, so here I'm going to find the distance between the centroid, okay, and the midpoint PR. Okay, so let's just recall that the centroid was given by 4/3, 0. Okay, and the the midpoint for PR was just 0, 2. Okay, so here we've got x2 minus x1, so 4/3 minus 0 squared, and then here plus y2 minus y1, so 0 minus 2 squared, and here we'll simplify, so 4/3 squared will just be 16/9, and here we have plus 2, -2 squared is 4, but let's write that as something over 9, so that's 36/9, and so here we have 36, 46, 52/9. Okay, so now let's compare to that other distance that we found from the centroid to the point Q. Okay, here remember that we had square root of 208/9. Okay, so how can we show that this is twice that? Because when you look at 208, you realize, wait a minute, that's 4 times 52. Okay, but I think we'll see that this is going to work out, because if I take 2 times square root of 52/9, okay, if I want to bring this 2 inside the square root, well, what's it going to become? It's going to become 4, okay, times 52/9. And when we do 4 times 52/9, we get exactly 208/9. So we have shown that the distance from, okay, and let's bring back this diagram here. We have shown that the distance from Q to the centroid is exactly 2 times the distance from the centroid to the midpoint. Okay, so we've shown that the ratio of those distances is 2:1. Now you could repeat for the other 2 sides, but I would suggest it's not worth the time, since there's quite a bit of work to continue. continue doing this. Okay, so that is it. This is one of the, again, classic properties of centers of triangles.